Okay, today we're going to talk about using Cramer's rule when solving systems of equations, and we're just going to be doing 2x2 equations today. The same concept applies for 3x3s, but just for this video we're going to be doing 2x2s. Okay? Okay, so you're given the system of linear equations right here, and you're told to solve it using Cramer's rule. Well, I suggest first to turn this thing into a matrix. Remember, we look at the lead coefficients when we do that. So this turns into 3, 1, so you have 1 in front of the y, 2, negative 6. That's to be multiplied by x and y to give us 2 and 5. Okay, so there's our matrix. Now, using Cramer's rule tells us, well, x is going to be equal to the determinant of our matrix, but we're going to replace the x column with the answers. Okay, so we'll denote that a sub x, and then we just divide that by the determinant of a regular matrix. Okay, so doing that, I'm going to take the determinant. Remember, it's not absolute value; it's determinant. We're going to take our x column here and replace it with our answer column. So we have 2 and 5. And then our y column stays the same. And that's going to be all over our original determinant 3, 2, 1, negative 6. Okay? Now we just compute both of these. So this one's not too bad. 2 times negative 6 is negative 12 minus 5. Remember, you multiply the diagonals and take the difference of them. Divided by negative 18 minus 2. Okay. 12 minus 5 gives us a negative 17. Divided by negative 18 minus 2 is a negative 20. That simplifies to 17 over 20. Okay. And that's our x value here. Not too bad. If you think about it using Cramer's rule too, it's an ugly x value if you were to use like substitution or elimination or something like that. Now you'd have to go back and substitute that in to find y. But we'll just use Cramer's rule again. Okay? So we're going to follow the same idea. So we know x equals 17 over 20. Okay? Now we're just going to find y. So y is going to be the same exact idea. But now instead of taking the determinant of this a sub x, we're going to take a sub y. So we're going to take our matrix here, take the column that y is a part of, and we're going to replace it with the answer matrix there. So I'm going to keep my x matrix the same, my x column the same. And now, instead of the 1 and negative 6, I'm going to replace it with 2 and 5. Okay. The nice thing about this, determinant of a stays the same. Still going to be negative 20. That's nice. Okay. Now you do the math here. 3 times 5 is 15 minus 4. So that number divided by negative 20. See, 15 minus 4 gives us an 11 over negative 20, or negative 11 over 20. So x equals 17 over 20, and y equals negative 11 over 20. Okay? So again, that's the nice thing about Cramer's rule, is you get answers that are ugly like this, but they're not too bad. You didn't really have to deal with them. You're just dividing fractions in. And one thing to note, these here, these bars, they don't mean a matrix. You're taking the determinant of a certain matrix. Okay? The matrix is kind of these brackets up here. So this is determinant, and you're taking determinants here. And remember, determinants, you take the diagonals, the products, and then you subtract. Okay? Cool. Okay, I'm going to put one up on the board for you to try. So after I write it up, pause the video, try it, and then come back and see if you got it right. Okay? I'll put it up real quick for you. So negative x plus 5y equals negative 16, and 4x minus 6y equals 14. So again, pause the video, try what we just did, and then come back and we'll check our answers. Welcome back. Okay, so hopefully first you turn this thing into a matrix. -1, 5, 4, -6. Multiply by your variables, your answers. Okay? And one thing, common question students have, they said, what do you mean the x column? Well, if you think when you're multiplying matrices, do your rows by your columns, you get -1 times x, which is this guy, 5 times y, which is this guy, equals -16. And then when you do this, you get 4 times x. So both of these guys right here have an x on them. So when we replace the x column with this guy, that's what we're doing. Okay? So x is going to equal the determinant, replace the x column with the answers, -16 and 14. Keep the y column the same. Beautiful. And the original one. Okay. This equals, let's see, what? 80 plus 16, so 96. So positive. Okay. Then minus 70. All over, and then you just find the determinant of this guy. 6 minus 20. Okay. Okay. That's going to give us a, what, 26. Over 6 minus 20 is 14. Again, the nice thing about this is you get some crazier numbers, but who cares? And that's going to reduce down to a -13. Divide each one by 2. Okay? So that's what we should have got for x. So keep it over here. X equals -13 over 7. Now for y, not much changes. Now we're just going to keep the x column the same this time. -1 and 4. And now we replace your y column with the answers. Okay. And remember, this guy stays the same, so we don't have to worry about that. Now 14 times -1 is -14. Okay. Now this we're got to be a little bit careful. So now it's 4 times 16, which gives us a -64. So it's minus a -64. Okay, many students like to put a -64 there, so be careful. Okay. So -14 minus a -64 gives us what, 50. They both share a factor of 2 again. So we can add that. Get 25. So x equals -13 over 7. Y equals -25 over 7. Okay? So hopefully that makes a little bit more sense to you. The idea of us just changing the column, so the x column stayed the same. We changed the y column, we're finding y, and same thing for x. And this guy is just the determinant of your regular matrix here. Okay? Hopefully that made sense. And look for another video on a 3x3.